本日は AWS サミット東京2016ジェネラルカンファレンスにご来場いただき誠にありがとうございます。アプリケーションのセキュリティ向上のためのエッジサービスの戦略とベストプラクティスと題しまして Amazon Web サービス VPH サービスプラサットカリアナラマンより講演させていただきます。それではプラサットさんよろしくお願いします。
Everyone, thank you for coming for the presentation. You're having a fun time at this the summit? Not hearing any voice. Yes? Okay. So we have a dense presentation. Security is the last topic that you want to have in the evening. I'm actually standing between you and the beer, but hopefully I'll make it as simple as possible for you. So what do you expect from this session? Well, I'll start briefly with why security matters. Then I'll get into the three aspects of security. I'll explain to you what AWS's edge infrastructure already does for you. And then I'll explain what you need to do to actually make your applications more secure. So why does security matter? Well, it's fairly simple. At AWS, security is our number one priority. It has always been our number one priority. It'll remain our number one priority. And the reason is, it's all about customer trust. There are very few things that you can do in your business which can actually be ending your business, and security is one of them. And losing customer trust would actually be a pretty bad outcome for your applications. Number two, it's about regulatory compliance. Okay? Regulations require that you actually run your applications in a very secure manner. Okay? 3 and 4 are about protecting your customers' data and protecting their personally identifiable data, which is PII data. So this presentation is not meant to scare you. There are many vendors who will actually talk about security being so important, and they use techniques to scare you. Well, this presentation is actually not meant to do that. What it's meant to do is to explain to you and assure you that AWS does a lot of things on your behalf, and you need to do something very simple to be able to secure your applications running on AWS. Well, here's an example to lay the landscape for you in terms of DDoSes that actually happen. In 2015, the 90th percentile of DDoS attacks, which means some of the largest DDoS attacks, were even less than 30 gigs. It's actually tiny. At the scale at which we are operating at AWS, that is tiny. Okay. And the average DDoS attack was only about 15 gigs. So the vast majority of these kinds of attacks can easily be actually mitigated by running on AWS. So here are some metrics about DDoS attacks. You can broadly divide DDoS attacks into two kinds. One is infrastructure. The other is application layer attacks. Okay. Infrastructure attacks are probably some of the most common kinds of attacks. They're easy to do. They're about 78% of the attacks that we typically see. Okay. Application layer attacks are harder to do. They're about 22% of the attack volume that we actually typically see. And because these are more complex, there are lesser occurrences of application layer attacks. Lately, we actually see attacks that have multiple vectors. So typically, you will see DNS reflection attacks, you will see SSDP floods, and so on. And that's something that has happened in the last couple of years, that we see rarely attacks of a single vector, but typically multiple attack vectors. Okay. But the good news is that most of these attacks are infrastructure layer attacks. They're volumetric attacks. And those are the kinds of attacks that AWS is advantaged in protecting for your applications. So there are three facets to security. And you will see me using this slide and these three facets throughout the presentation. Number one is infrastructure security. This is about how AWS provides security for you. There's little to nothing that you need to do for infrastructure layer security. Number two is services-based security, which is about all the security that we've built into our services that you can use to actually secure your applications. And the third kind is application security. Okay? And this is about what you need to do to secure your own applications. And throughout the presentation, I will explain each of those. So again, infrastructure security is how AWS secures the infrastructure you rely upon. Throughout the presentation, I'll actually have two categories. Okay? Box one, which has the DNA symbol, are the things that AWS does on your behalf. Box number two, which has the human face in there, are the things that you need to do using the capabilities that AWS has built for you. Together, they actually secure your applications. So as part of infrastructure security, it's about physical security, it's about network layer security, and security against layer 3 and layer 4 DDoS protection. All those things are things that AWS automatically does for you using its entire edge network. So in terms of physical security, access to those production boxes that your applications are running on is highly secure. We have physical security. We have cages that are actually protecting the services that we actually run at the edge of the network. We have things like two-factor authentication. That means even our own internal developers, when they have to access the production boxes, have to use a combination of physical devices that they have to actually use before they can get access, in addition to passwords. The security containers are restricted. That means that for different applications and different services, the credentials that we use are different, which means that if we ever actually have a security issue with one of those credentials, it restricts the blast radius of that specific event. And we have a bunch of metrics that we are constantly monitoring about our infrastructure. And all of this physical security and the processes that we actually automatically employ on your behalf gives us things like PCI compliance, ISO 9001, 27001, and so on. Okay. In fact, CloudFront is actually certified as a PCI compliant service. Now let's talk about the network layer security and the protection against DDoSes. And the one key thing that I want to talk about is what we call as always inline protection. Okay. When you look at traditionally how DDoSes have been mitigated, you have these DDoS providers or anti-DDoS providers who have infrastructure that actually runs on the side where you have to shunt your traffic to this infrastructure. When you have a DDoS attack, it'll scrub this DDoS attack and it'll give you clean traffic into your applications. There are three problems with this approach. The first problem is that when you have to shunt this traffic all the way to this new infrastructure, your DDoS traffic, as well as your application traffic, is now seeing increased latency. Okay. Number two, what it means is that you've now increased your MTTR, or mean time to recovery, from a DDoS attack, because you have to shunt all this traffic to another infrastructure before you get clean traffic. Number three, we fundamentally believe that any service that actually is brought in line only when there is a DDoS attack may not necessarily work. Okay? And that is the reason why we spend a lot of effort over a many number of years at Amazon, securing Amazon.com and AWS in building what we call as always inline technology. And what always inline is that a set of hardware and set of services that we've custom built that fronts our edge infrastructure, which means all your traffic, whether it is malicious traffic or regular traffic, is constantly going through that infrastructure. We're constantly monitoring every single packet coming to your application. We're constantly scoring each of those packets, which means those three disadvantages that I talked about with other DDoS products, you don't have. It's always in line, so you don't introduce any latency for your legitimate traffic as well as your DDoS traffic. Number two, it reduces MTTR because it's always protecting your applications. You don't have to shunt any traffic when a DDoS happens. And because it's always in line, you don't have to worry about whether this service is going to be effective when there is a DDoS attack. So there are 4 categories of DDoS mitigations that we actually employ at the edge. Okay? The first one we call as basic hygiene, which is we look at all the packets that are coming in, and if those packets are malformed, an example is TCP checksums, which are incorrect in the packet, we just automatically drop it. The reason why we do that is there's no point in sending that traffic to your application. Your application is not going to be able to deal with it anyways. So we automatically drop that traffic. The second kind is what we call as traffic prioritization. Because I talked about always in line, we're scoring every single packet that comes into our infrastructure. So we have a scoring scheme that scores between legitimate traffic and malicious traffic. And we don't have to drop any traffic unless it causes a problem for your service. When there's a problem for your service, we automatically drop the most malicious packet. And this way, we've actually prioritized your entire traffic coming into your application. Number 3 is what we call as distribution signatures. And this is a technique that we actually employ. It's actually a pretty smart technique. So many people actually use Route 53's hosted zones. So Route 53 is a DNS service. You can actually create a zone within Route 53. It'll answer DNS queries for you. And when you create one, you get a unique set of name servers. And the reason why you get a unique set of name servers is because when we see a volumetric attack against a specific set of IPs, we can immediately know the zone that is getting attacked. Okay? Just by knowing the IPs that are getting attacked, we can figure out the zones that are getting attacked. That leads me to the last part of it, which I call advanced traffic engineering. And what that is that we can actually, because we control your IP space, we can move that traffic to different layers in our network. We can move it between edge locations. We can move it between carriers. We can move it to sites that have better connectivity, and so on. And what that lets us do is to isolate attack traffic from legitimate traffic. And all of these techniques are done automatically without human intervention. And we spend a lot of time automating it because we fundamentally believe that humans, when they're involved in manually mitigating attacks, will just increase MTTR. Now, why am I talking about edge network? Well, there's a very specific reason for it. And this is an example of a service that we actually released that is automatically fronted by CloudFront. Many of you may not know this, but CloudFront is fronting API Gateway. And there's a reason for that. There are 2 reasons, actually. The first reason is that by fronting it with our edge network, we're terminating TLS connections closer to end users. And that's better from a latency perspective. Okay? The second reason is you get all those DDoS protections for your APIs as well that I just talked about. Okay? So the edge network provides you defense in depth, and you want to stop all these attacks as close to the end users as possible, and you don't want that attack to come deeper into your network. Now let me talk about services security. And again, to recap, this is security options that we've built into the services that you can utilize. Okay? So again, going back to things that we do on your behalf versus what you need to enable on your applications. I'll discuss that separately in the subsequent slides. So CloudFront automatically protects data in transit. And here's what that means. Your data is moving from your end users through a set of network layers back to your origin. And by fronting all of those services with CloudFront, we're actually securing a large part of your data in transit. Between your edge network and your actual origin is automatically protected. It can be protected because it goes on a private backbone that we actually control and manage. Two is you can enable HTTPS between your viewer and CloudFront and between CloudFront and your origin. And that origin can be either on AWS, can be your own custom origin in your own data center if you have not migrated to AWS, and that entire connection is now secure. CloudFront also enables advanced SSL features automatically for you. And what is that? By definition, we prioritize the more secure ciphers ahead of the less secure ones. So if you have a modern browser that your end users are using, the more secure ciphers is how they'll negotiate with CloudFront. Okay. Number two, you also support what is called as perfect forward secrecy. And what that is securing the connection not just from your viewer to CloudFront, but also from CloudFront all the way back to your origin. And I'll discuss that more later. Now, in terms of performance, the reason to actually front your application, whether it's running on ELB, or whether it's running on, with an origin on S3, or your custom origin or EC2, is so that we can actually do things like SSL termination at the edge, which is better from a performance perspective. We also do things like OCSP stapling, which is about sending the entire certificate chain back to the viewer so that the viewer or the browser does not need to do that negotiation separately. But there are things that you need to do. And many of these things are made easy for you, okay? And here I'll talk about two concepts, which is how do you secure using what I call as full bridge security and half bridge security. And I'll explain that in detail in the subsequent slides. But it's all about SSL connections to CloudFront and SSL connections from CloudFront all the way back to the origin. And the moment you do that, it's much harder to attack your application because trying to create a DDoS attack on an SSL connection is very hard. There are three options for you to turn on SSL. The first one is by far the simplest one. You just turn on SSL and you get a default CloudFront domain name, d123.cloudfront.net. And this is sufficient if you're not really exposing your domain to end users. Okay? But let's say you have to, and you don't want the ugly domain name like cloudfront.net. You can use an option called SNI. And this is pretty much supported by most modern browsers. And it's available for you for no extra cost. The third option, if you do care about some of the older browsers, is dedicated IP custom SSL, where we would dedicate a set of IP spaces for you for your SSL transactions. Now, we also make it easy for you to get a certificate on AWS. We recently launched a service called AWS Certificate Manager. And what Certificate Manager does is it will give you a certificate, and you can install it on CloudFront or on ELB for no extra cost. And the best part of it is you don't have to ever worry about your certificate expiring. It'll automatically renew that certificate for you as well. Now I'm going to talk about a customer use case. Mapbox is a customer who sells map tiles. And map tiles are basically maps that you can embed within your application. So for example, if you're building an application for a restaurant and you want to embed a map within your application, you can install this widget from Mapbox and let your end users go and look for directions to your restaurant and so on. Okay? So they actually use SNI custom SSL because most of their access comes from modern browsers. But they also wanted an economical option, which means that they didn't want to actually use SSL for all their use cases. Okay? So for instance, the image of Mapbox, it doesn't matter that it has to be on a secure connection, but the addresses that customers enter, that has to be secure. Okay? So they needed an option to do that. And this is where I talk about two patterns, half-bridge TLS termination and full-bridge TLS termination. And I'll explain with a schematic what this means. So a full-bridge termination is you have SSL connections all the way from the viewer back to CloudFront, all the way to your origin. Okay. A half-bridge termination is nothing but SSL from the viewer to CloudFront, but then from CloudFront back to the origin is regular HTTP connections. Okay. And what Mapbox does is that for specific set of use cases, like their APIs, they actually use full bridge. For things like images, they actually use half bridge. And this one is very easy to configure. In CloudFront, there's a checkbox which basically says match the viewer's protocol. And what that does is that if the client came on a secure connection, it'll be secure all the way back to the origin. If the client came on an unsecure connection, it'll be unsecure all the way back to the origin. So now as an application developer, you can control which ones need to be on SSL, which ones need to be on non-SSL. So that's what I talked about. They have multiple origins. They have API endpoints, which actually some of them they run on their own on-premise locations. They use half bridge for some of those use cases like images. They use full bridge for more secure data. So are you done yet? Well, you're not. You need to now protect your application, right? All I talked about primarily is all about the network layer, right? So now let's talk about the application, what you need to do. And here as well, AWS has a bunch of capabilities that makes it easy for you to secure your application, okay? So here, let's say you wanted to deliver your content only to a certain set of users. For example, users coming from a certain set of IPs or users based on time. A common example is you have a login page. Once people log in, you want that session to be valid only for a certain period of time. And after that, you want to ask them to re-log in. And this is where we have two concepts called signed URLs and signed cookies. What this is that you can sign the URL that your customers use to actually access your application. CloudFront will validate that signature. It will check to see whether it is coming from a legitimate source. And if it is, it'll serve that content. Signed cookies is the same concept. So you would use signed URLs if you have a set of individual files and you just want to secure access to those individual files. But let's say you have a video application which has a lot of files. For you to go and secure every single URL is very time consuming. And there you would use signed cookies, where your customer would log in, you would set a cookie back, and then the cookie would come back to CloudFront when they actually access those different segments. And we would validate the cookie and only then return it. Another use case is if you're under development mode. So for instance, if you've actually gone ahead and built a set of applications where your developers are testing it, you can secure access just for those set of users. You're not done yet, okay? What if you're running your applications in your own data centers? How do you secure your origin for it? Now this is where we've released a service called AWS WAF. We released it at reInvent last year. And what AWS WAF does is it actually starts protecting you against any kind of layer 7 attacks. As I said, we talked first about network layer security. We're slowly moving towards application layer security, right? So let's say you have a bunch of requests which are coming in from bad bots or malicious IPs that you don't recognize. You can actually automatically stop that using AWS WAF. Mapbox actually uses AWS WAF. And when we built AWS WAF, our fundamental tenet was that we want to build it such that you as application developers can automate your entire security chain. Okay? And what Mapbox does is it actually uses AWS WAF, which is fronting their application. AWS WAF then sends all their log files to their threat analysis system. The threat analysis system consists of an S3 bucket where the logs are going to be delivered, has a Lambda function that's constantly looking for, analyzing their logs, and it looks for bad IPs. When it detects a bad IP, it sends it to their rule updater system, which then calls the WAF API and puts a block on that IP. And they do all this in a completely automated fashion. In fact, they have a pretty cool demo of this. If you go to the AWS WAF homepage, you can see some of these. So there are 4 kinds of things that you can actually automate with WAF, which are very common. Okay? And this is in addition to some of the capabilities that are turnkey on WAF. The first is what I call as IP reputation lists. These are open source IPs that you can actually get from open source products called Spamhaus. And they maintain a list of bad IPs, and you can actually import that directly into WAF. Number 2 is protection against HTTP flood attacks. And this is the kind of automation that Mapbox did, which is they look for IPs that are actually creating a lot of requests, and they rate limit those IPs. Number 3 is scans and probe attacks, which is these are attacks from sources that look for all kinds of different files, and you may return a 400. And you look for those kinds of attacks, and you can say, oh, I'm returning a 400. Well, my application should never return a 400 because I know the files that I have. And you can automatically block that. Sorry. And the last kind is bad bots. Okay? Your robots.txt tells you how good bots should behave. And when you have bots which are not following what you've specified in your robots.txt, you can automatically block it. All of this is open sourced. You can go to the AWS WAF website and you can download the code for it and you can install it. The other thing that we actually provide is CloudTrail integration. And what that means is that, let's say you've actually set up your application, and now you want to find out who's actually making changes to my application. You want an audit trail of all the people who are making changes to your application. CloudFront is automatically integrated with CloudTrail. So anytime someone makes a change to your configuration, you have a log of who changed it, when they changed it, what they changed. Okay. The final section is about application security. And the number of slides on this is very, very small, just only a couple of slides. There's a good reason for that. The reason is many of the things that you need to do to secure your application is already taken care of by AWS and its edge network. Okay. As I said, infrastructure security is taken care of for you. Services security, we do a lot of tools. We provide a lot of tools for you, and you can use those tools. And application security is where you need to do some things on your application layer. And here as well, we provide you a lot of tools for doing that. And that's the next set of slides I'm going to talk about. And here's the reason why you need to do that. While you can front your applications with things like CloudFront, well, your origins have to be secured as well, because hackers couldn't bypass CloudFront and go directly to your origin. So how do you protect that? And here we have 2 concepts. The first one is called origin access identity. So if your origin is actually on S3, you can prevent access to your S3 bucket and only give access to CloudFront to access that bucket. Okay? So anytime S3 gets a request from anywhere else other than CloudFront, it'll reject that request. The second kind is called custom origin. So let's say you have your origin which is running on EC2, ELB, or your own data center. How do you secure that origin? And here, we released a capability called Shared Secret. So between CloudFront and your services, you can share a secret, and CloudFront will always send that secret back to your origin. At your origin, you can check for the existence of that secret. If the secret doesn't exist, you can safely reject that request because it wasn't a request from CloudFront. Some of the other origin best practices, there are about 6 of them, but they're all fairly simple. First one is you can enable higher levels of secure protocols at your origin. So let's say your viewer is coming from some of the older browsers, you can allow TLS 1.0. But then between CloudFront and the origin, you can say, I can only accept TLS 1.2. And so the negotiation back to your origin is on a much more secure protocol. Okay? The second kind is you can restrict access through security groups and the shared secret that I talked about. The third kind is that you can actually install a SHA-256 certificate. Okay? And this is something that you can get from ACM already. What if you're running your origin on ELB? Well, CloudFront can actually front dynamic content as well. In fact, there is no extra charge for dynamic versus static content. So you can be running your origin on ELB, you can front that with CloudFront. You can run your static assets on S3, you can front that with CloudFront as well. There's a lot of advantages of actually fronting ELB with CloudFront. One, there's a performance advantage because we actually have persistent connections back to ELB. 2 is you can actually install a certificate on ELB from ACM, and you can ask CloudFront to only negotiate using that certificate. Okay. 5, you can turn on specific ciphers on ELB. So the more secure ciphers you can turn on, and CloudFront will only negotiate using those secure ciphers. And the last one is a slightly more nuanced or a slightly more advanced capability, which is called HSTS headers. And this is secure headers that you can put into your application that will prevent you from ever negotiating without some security parameters. So now you've done all that, okay? You've taken care of the benefits of infrastructure security. You've done the right set of things based on services security. You used things like AWS WAF. You've fronted your application with CloudFront. You've put all the application security best practices. How do you know that application is really secure, that you didn't miss a step? And here, there's an open source website called sslabs.com. Okay. It's a pretty impressive site. You can go to sslabs.com, input your domain name, and it'll give you a fairly clear report that tells you, is your website secure? It'll check the certificates that you use. It'll check whether you're actually doing connections over SSL. It'll do all kinds of other things for you. And this way you can validate if your website is indeed secure. So to recap, there are 3 modes of security, 3 aspects of security: infrastructure security, services security, and application security. Infrastructure security is everything that we do on your behalf. Okay? You already get that as part of running on AWS. Services security are all the features that we've built into our services that you can enable for your application. And number 3 is application level security, which are the things that you need to do at your application layer. Okay. So while this is scary when you talk about security, it is actually really very simple when you just follow some basic tenets like this. Thank you very much.
倉里さん、ありがとうございました。